Hello and welcome back to the RLR method. If you have been following this channel now, you would have seen that how we break down the concepts into simple steps so that we understand the math behind it rather than just memorizing the formulas. In this series here, we have been doing HCF and LCM of whole numbers. Now, my question is that what if the numbers are not whole numbers? Can we find the HCF of fractions or maybe decimals? So, if yes, so how we do that, we'll find it out here. So, in this video, we are going to see how we find the HCF and LCM of fractions and decimals. Now, as we said, we break down the concept into simpler steps. So here we go. The step one here is we change the fractions into their simplest form. For example, we have, let's suppose we have fractions as 2 upon 3 and let's say 4 upon 9. And we have to find the HCF of these two fractions. So this is already in the simplest form, so we don't need to do anything. The next step here is to find the HCF. So finding the HCF means we find the HCF of the numerators, which would be 2, 4, and LCM of denominators, that is 3 and 9. So HCF of 2 and 4 would be 2. LCM of denominators 3 and 9 would be 9. So 2 upon 9 is the HCF of these two fractions. Now let's look at how to find the LCM of fractions. So first step remains the same. Change the fractions into their simplest form, and next step to find the LCM of these two fractions would be, in this case, we find the LCM of the numerators. So we had numerators as 2 and 4, and the HCF of denominators, that is 3 and 9. So LCM of 2 and 4 would be 4, and HCF of 3 and 9 is 3. So you have 4 upon 3 as the LCM of these two fractions. Okay, right. So now let us look at the decimal numbers. How to find the HCF of decimal numbers. Again, first step, we remove the decimals by multiplying both numbers by the same power of 10. Let's work this out with the help of an example. So let's say we have 1.2, let's say 1.8. We have 1.8. And we have to find the HCF. So before finding the HCF, we have to remove the decimal. In this case, 1.2 has to be multiplied by 10 to the power 1 so that we get a whole number. Decimal removed here. 1.8 is also to be multiplied by 10 to the power 1 to make it a whole number. So that here we get 18. Now, since we've got the whole number, so the process of finding the HCF of whole number remained the same as we had been doing it earlier also. So that would be 12 and 18. And the HCF of 12 and 18 would be 6. LCM of 12 and 18 would be 36. Okay, so this is, we have just calculated, we have just identified the HCF and LCM of the whole numbers. Now there's a third step as well. So we divide both answers by the same power of 10. So our answer, we have to divide H6 by 10 to the power 1, which is 0.6. And the LCM we had got in our previous step was 36. So we divide 36 also by 10 to the power 1, and hence we get 3.6. So this is how in 3 simple steps we find the HCF or LCM of decimal numbers. So here is a quick recap that first thing is HCF and LCM can also be calculated for fractions and decimals, as we learned in today's video. For fractions, we need to work separately with the numerator and denominator, and for decimals, we convert them into whole numbers, solve the problem, and then adjust the answer. Okay, so here you have a practice problem for you. You have to find the HCF and LCM of the numbers that are given, and pause the video here, try to solve it, and then at the end of it, I have also shared the solution, and you can compare your steps with the solution as given. So that would be a part of our reflection, and reflect, if you have made any errors on it, reflect and try to rectify. And if you got a correct answer, please drop your answer in the comments. Has helped you, please do not forget to like the video, share it with your friends, and subscribe to the channel for more interesting, simpler mathematical solutions. Take care. See you in the next.